Hello everyone, welcome back to my channel Science Sutra. In this video, we are discussing with an interesting concept. Okay, that is, we have to study the refraction phenomenon through rectangular glass slab. Why we need to study this rectangular glass slab, refraction through rectangular glass slab? In order to know more about refraction. Okay. See, before knowing or before discussing this topic, okay, let me revise with the few concepts which I discussed in my previous videos. Okay. See, the important concept which is required to study this is, see, if I take a medium, this is medium 1 and this is medium 2. Okay, the medium 1 I will consider that as a rarer medium and this one medium 2 as denser medium. What I will do here, I will take an incident ray falling on the medium, falling on the boundary that separates medium 1 and the medium 2. Okay, since the ray is traveling from rarer medium to denser medium, how the ray will behave, I told in my last video, right? See, when the ray is traveling from rarer to denser medium, always you will see the change in the direction of the path of the ray of light, how it will go. After refraction, it will go in this direction. That means here the refracted ray is bending towards the normal, correct? It is bending towards the normal, and here this is the angle of refraction and this is called the angle of incidence. In this case, what you can take, the angle of incidence is greater than the angle of refraction. Okay, this one concept we have to know before studying that refraction through rectangular glass slab. Okay, one more topic, one more concept is, I had to consider an incident ray where it is moving from denser to a rarer medium. Okay. Yeah. Here we have to consider the ray that is passing from the denser medium to rarer medium. What is denser? What is a rarer? I had given the definitions in my previous video, right? The rarer medium is called to be a medium where the speed of light is more. Okay. If I call that medium as a denser medium, then the speed of light is said to be less. Okay, then that medium is called to be denser. And if the speed of light is more, okay, if the value of the speed of light is more, then that medium is called to be the rarer medium. Okay, in this case, if the ray is traveling, okay, from denser to rarer medium, how the ray will behave? After refraction, the ray will bend away from the normal. That is the important point here. So, what you have to take here? The I value is less than the R value. Okay. These two things we have to know before studying the refraction through rectangular glass slab. So, if we want to study the refraction through a rectangular glass slab, okay, what we have to do? First, we have to take the rectangular glass slab. Okay. We have to take the rectangle. Okay. We have to take the rectangular glass slab and we have to denote that as A, B, C and D. Okay. First we have to consider an incident ray, which I will designate that as E and F. Okay. This incident ray is meeting the rectangular glass slab at the point O. Okay. So I will write O here. What I had to do, I need to draw the normal. Okay. So I will draw the normal. As the ray is traveling from where? It is traveling from the air medium to the glass medium, correct? So the air is called to be the rarer medium and the glass is called to be the denser medium. Why? Because the speed of light in air is more compared to the speed of light in glass. So how the ray will bend after refraction? As I told, since it is traveling from rarer to denser medium, it has to bend towards the normal, correct? So this is the refracted ray, and I need to draw the angle of incidence and the angle of refraction, correct? And this refracted ray is again meeting this rectangular glass slab at the point O prime, correct? So I need to draw the normal there. I need to draw the normal, but here in this case where the ray is traveling, from where it is traveling? It is traveling from denser medium to the rarer medium. So how it will behave, how it will refract after refraction? The refracted ray will move away from the normal, correct? So if we extend this incident ray, okay, if we extend this incident ray, okay, if we extend this incident ray, we are getting that, okay, you can write here, this you can represent it as O prime H. O prime H represents the one more refracted ray when the ray is traveling from denser to the rarer medium. O prime H, which I denote O prime H, is the emergent ray. Okay, you will call that ray as the emergent ray. Okay, this O prime is the refracted ray, correct? It is the refracted ray, and EF represents the incident ray, correct? So here O prime H, O prime is the refracted ray, and you can say that refracted ray as the incident ray also, correct? Why? Why? Because this is the incident ray which causes the refraction from denser to rarer medium, and we are seeing the ray to be bending away from the normal, correct? So here also you can see this is the angle of incidence and this is the angle of refraction or the angle of emergence. Okay, here one point you have to note down. What is that point? The angle of incidence, is equal to angle of emergence. Why? Can you say why? I is equal to R. Why? Yeah. Here, let me change the designation so that we will not get confused while writing the reason. Okay. This is I1 and this is R1. Okay. And here the angle of incidence. If you see this represents the angle of incidence I2 and this represents the angle of incidence R2. Okay. Why is the angle of incidence is equal to the angle of emergence, or else you can say the amount, or else you can say the incident ray, the extension of this incident ray, right? This is the extension of the incident ray. Why the incident ray is parallel to the emergent ray? That is also one question, right? Okay, I will write in one more page. why the incident ray, okay, is parallel to the emergent ray. This is an important point which you have to note on. Okay, why? See, if we consider this is the rectangular slab, okay, and this is the incident ray, and to this we have to draw the normal, and after refraction how it will behave or how it will bend towards the normal, correct? And this is the angle of incidence and this is the angle of refraction, which I will mark that as I1 and R1, okay. And here this is again going under refraction, where you will see the refracted ray to be moving in this way, okay. This is R2 and this represents why is the incident ray is parallel to the emergent ray. Think it. See here, this is the incident ray, correct, and this represents the emergent ray. This incident ray, if I extend back, you can extend like this, right? If I extend like this, you will see these two rays. This is the emergent ray and this represents the incident ray, correct? Why it is parallel? If you think for an answer mathematically, how can you solve this? As we all know, what we know, the exterior alternate angles. The exterior alternate angles will always be equal. That means what I need to take? I need to take the angle of incidence I1 is equal to the angle of emergence R2. Correct? If I take this, the exterior, this is the exterior, and for this is the exterior. The angle of the exterior alternate angles, if I take this angle of incidence I1, the angle of emergence R2, these two angles are equal. Correct? As a result, what we can say? The bending of light at the point O, is equal to the bending of light at the point O prime. As a result, we are seeing that incident ray is parallel to the emergent ray. Okay, the extent of bending of light at the point O is equal to the extent of bending of light at the point O prime. That is the reason why we are seeing the incident ray is parallel to the emergent ray. This point is very much important. Okay, you have to note down this point. Okay, please note down in your notebooks. This point is important. Okay, they may ask in your exams like, if the incident ray, why the incident ray is parallel to the emergent ray? Give reason. Why? Because mathematically, if we are speaking, how we can solve this? The exterior alternate angles. These are the exterior alternate angles. What are the exterior alternate angles? This I1 and R2. These are the two exterior alternate angles. These two angles are equal. As a result, what we can say? The extent of bending of light at the point O is equal to the extent of bending of light at the point O prime. As a result, we are seeing the light ray to be parallel. The incident light ray is parallel to the emergent light ray. Okay. If you want, you can write down here. This represents the incident ray. This green line represents the refracted ray. And this is first refracted, correct? And this again is called to be the incident ray, but here I had to take the second incident ray, and here this white color represents the emergent ray. Okay, emergent ray, and this is called R2. Okay, this is how we can explain the refraction through rectangular glass slab. Here two important concepts that we have to keep in mind. What is that? When the light is traveling from a rarer to a denser medium, how the light ray will get refracted. It will refract towards, or it will bend towards the normal. As a result, we are seeing the angle of incidence. In the first case, the angle of incidence is greater than the angle of refraction. In this case, what we can take? In the second case, we can take the angle of incidence is less than the angle of refraction. Why? Because the ray is traveling from denser medium, that is glass medium, to the air medium. That is the reason we are getting the angle of incidence is less than the angle of refraction. Okay. From this, we will come to know that a refraction phenomenon is all about the bending of light ray when it is traveling from one medium to the another. And we also know that why the bending of light ray takes place, because the speed of light changes when it travels from one medium to the another. As a result, we are seeing the bending of light ray, and that phenomenon is called to be the refraction. As we all studied that reflection is a phenomenon which is an optical phenomenon, and it holds some laws, right? See, if I want to say a phenomenon is called to be a reflection, it need to satisfy two laws. What are the laws? The angle of incidence, I will write down. What is the laws of reflection? Laws of reflection. What is that? The angle of incidence is equal to the angle of reflection. Correct? So that is I is equal to R. So next law, what is that? The incident ray, the reflected ray, and normal drawn to the surface all lie in a same plane. Correct? These are the two laws which we will famously call as the laws of reflection. These two laws need to hold good if I want to say that phenomenon as reflection. Similarly, in the same way, there are some laws of refraction. Even the refraction phenomenon also holds some laws. Okay, as we know, the laws of reflection, there are two laws, correct? The second law is the first law for the law of refraction with some changes. What is that? I will say. Okay, the incident ray, okay, the incident ray, in the place of reflected, you have to take the refracted ray, okay, the refracted ray, okay, and the normal drawn to the surface, and the normal drawn to the surface separating two medium, at the point of incidence, correct? At the point of incidence, all lie in the same plane. Okay, little changes we had to do, okay, for the first law of refraction, which is same as the second law of reflection, correct? And here, what is the ratio of sine of angle of incidence is equal to the sine of angle of refraction. Okay, it is constant for a light of given color, correct, and constant for a pair of medium. What do you mean by that? See, if you are taking air and a glass medium, whatever the refractive index that you are getting, it will be constant for that medium. Okay, and if you are changing that air to water or air to glass, whatever the ratio of the pair of medium, it will be constant only for that medium. It will not same or it will not be equal to some other medium. That is the meaning of that. Okay, for a given color and constant for a pair of medium. And one more thing, how we can write this? It is equal to sine I by sine R. This sine I by sine R is equal to a constant. Okay, and that constant is called refractive index. Okay, refractive index. And this law, that is sine I by sine R is equal to a constant, is called to be the Snell's law. Okay, and this law holds good only for the angles. That is, the angle of incidence, either it should be greater than 0 or it should be less than 90. Okay, if it is like this, then this law holds good. Okay, and this sine I by sine R is equal to a constant, and that constant is called to be the refractive index, which we will denote that as N, small n. And here I is called to be the angle of angle of incidence, and R is called to be the angle of refraction. Please don't write reflection here. Okay, this is refraction. This is all about the refraction through a rectangular glass slab as well as the laws of refraction. Okay, if you like this video, please like, share and subscribe to my channel Science Sutra. In the next upcoming videos, you will see the practical part of this rectangular glass slab. How we can see this, will get to know more about the refractive index in my next class. Thank you.